Hello Python programmers. So we're in our next lesson now where we're going to learn about the REPL, R-E-P-L. We're going to learn how to use print statements in the serial monitor, which can be really useful when we try to figure out what's going on in our program. We're going to learn about for loops, and we're going to change the pixel brightness. So with that said, let's go ahead and dive in. First thing I'm going to do is I'm going to launch Mu. Actually, before that, I'm going to plug in my Circuit Playground Express, so make sure that's plugged in. Then I'm going to go ahead and I'm going to launch Mu. And what you'll probably see in here is whatever you had last worked on, and if you saved it to your Circuit Playground Express, it's code.py, which is probably loading up here. And you want to make sure that you've saved this, just double-click it and save it as a recognizable name to whatever folder that you had. So I've been saving things into my CPX code folder. I'm not going to bother doing that right now because I've already saved flash red, white, and blue there. But what I am going to do is I'm going to start my new application here in my Circuit Playground Express. You know what I'm going to do is I am going to call this pulsing lights, and I'm going to get rid of everything that's inside of the true loop, and we're going to deal with this in just a bit. But before we get there, I want to describe this thing that's called the REPL. And what the REPL allows us to do is it connects to the Circuit Playground Express, and it allows the Circuit Playground Express to execute line-by-line code that we'll type in. So I'll show you how we get there. With the CPX plugged in, then you click on this thing that says serial up here. And now this window called the serial monitor opens in the bottom, and we can make this larger or smaller too just by clicking on the pane in here. But about a third way is a good size for that. Then what we're going to do is click inside of the window and then hold down your control key and type C. Now, you'll see it'll say press enter, any enter key to enter in the REPL. We'll press that and you should see these three greater than symbols right in here. Now what REPL is it stands for read, evaluate, print loop. So what's going to happen is whenever we type some stuff in real time, our Circuit Playground will evaluate that, and then it'll also show us or print out the results of this if we use a print statement right here into our serial monitor. So what I'm going to do right here is I'm going to use a statement we've never used before, print, P-R-I-N-T, all lowercase. I'm going to open parentheses here. I'm going to type in a double quote, and I'm going to say, "You are awesome!" Exclamation point, close with double quotes, and then close with a closing parenthesis. And watch what happens when we press enter here. It says, "You are awesome," and you are indeed awesome. You're using the REPL. Now, what's neat about REPL is it'll allow us to experiment with different things and get different things happening. So, for example, we can actually send commands to the CPX and get it to do things, but if we want to use any of the features on the CPX, what we need to do is we first need to type into the REPL this statement up here, the for Adafruit Circuit Playground.express import CPX statement. So what I'm going to do is I'm just going to copy that because I know this one works. I'm just going to do a Command C, and then I'm going to click down here in my serial monitor, and I'm going to do a Command V. Again, it would be Control C and Control V on Windows. Press enter here, and you don't see anything that happens. And that's because, all this is doing is it's loading in these libraries. But now in the REPL, I can do anything on the Circuit Playground. So if I want to do something like, say, turn all the lights blue, I can say cpx.pixels.fill, and then two open parentheses, and then I can say 0, 0, 255, close parenthesis, press enter, and all of a sudden you should notice that your CPX turns blue. Now, well done, but man, that's bright. Wouldn't it be nice if we could turn the brightness up or down? Well, we can actually do that, and I'll show you where we can find out some more information about that. Now, to find out more, what I'm going to do is I'm going to consult the online Circuit Playground Express documentation for CircuitPython. And I gave you the URL for this in the previous video. Again, this is the page that it's for Adafruit CircuitPython, the Circuit Playground Express library. And so we're in this area that says API reference. So, you can go and find this or search for it on the web if you want to. But this is really useful. My students know in class we've covered API as an application programming interface. And essentially, that's something that a company writes to allow others to engage with their product or services. So Python out of the box doesn't know about Circuit Playground Express, but what the Adafruit folks have done is they have written an API or a library that gives us extra functions to be able to allow the CPX to do stuff. And when we type in this line into our code from Adafruit underscore circuit playground dot express import CPX, what we're essentially saying is, hey, go out there, grab all this extra Adafruit code, and if you want to use it, we have all of these different commands. Like if you wanted to get data out of the accelerometer, you just do dot acceleration. There's some sample code for you to see down here. We can see how you can identify the buttons and whatnot. And so if we scroll down here, we've already been dealing with the pixels information. Here we see that there's pixels down here, and this is some of the stuff that we've typed in here to be able to get our pixels to show, and we also got individual pixels to show as well. But what's interesting for us right now is it actually says here, see neopixel.neopixel for more information. Now, unfortunately, the documentation isn't super intuitive, especially for the new programmer. But if you click on this thing that says neopixel.neopixel, this actually includes a whole bunch of additional commands that exist. Even though it says neopixel strip driver here, and will eventually work with neopixel strips, we can just put this as in dot notation, dot, and any of these particular values. So you see how it says dot brightness in here? We can actually use that to set the brightness from 0 to 1, where 1 is full brightness and 0 is completely off. And the way that we do this is we'll actually just do cpx.pixels.brightness, and then we'll say equals, and it'll be one of these numbers. So let's go ahead and actually give that a shot and see if we can do that right in the REPL. So here we are back in our the REPL area. So the serial monitor is open in Circuit Playground Express, and our CPX is plugged in. And we're going to type in cpx.pixels.brightness equals 0.0, press enter, and whoa, the Circuit Playground Express turned off, which is just awesome. I wonder what would happen if we use another value in here. Let's try to do cpx.pixels.brightness equals, and how about 0.2, just to see how that looks. So press enter there, and it says, oh, it says an error, and this is good to see because I'm glad that I typed in the error. I'm not going to change things. Look, I typed in CPX incorrectly. So again, you know, the computer is going to really be very precise about, or very demanding about what you type in. So I'll type in again, CPX pixels.brightness equals 0.2, and sure enough, you can see the CPX turns on a little bit. Now let's go ahead and turn this to full brightness. So CPX pixels, and by the way, let me show you another technique too. If after you have the three greater than symbols right here, if you just press the up arrow, what that will do is it will go through the last commands that you typed in. So you can see I'm up arrowing, there's the error that I made. I pressed it 3 times here, so I went down to brightness 0. So you can go ahead and change those, and since I only want to change the last value, what I did was I went down. So again, you can go up arrow to do the previous commands, or down arrow if you want to work back into the most recent commands. And what I'm going to type in here is, after I've got CPX pixels brightness in here equals, I'm just going to do 1.0, press enter, and it's at full brightness. So nice. Let's go ahead and just, so it's not annoying you, you can say, you can turn the brightness down to 0. I'll just do the up arrow here, and I'm going to backspace over and set my CPX brightness back to 0. Now, what would be really neat is if we could go through and slowly creep up from a brightness of 0.0 to a brightness of 1.0. So we don't just see it flash, but so that it could sort of pulse up. And it would be really cool if we could pulse down as well, sort of slowly changing our increment, maybe 1/100th at a time. Now, in order to do that, we would need to loop through and then change the value. And in order to do that, we're going to learn something called the for loop in Python. It's very, very useful and allows us to go through and iterate or loop through something a certain number of times. And we can even change a value in a particular range of values each time we go through. So if we want to go through from 1 to 10, for example, we can start with 1, 2, 3, 4, and each time we go through the loop, the value will be a different value. Let's see how that works. Let's take a look at a slide that I prepared here, and we'll focus just on the first part up here. So the syntax for a for loop in Python is it's for, and then what you're doing is you're going to say, okay, this is going to be a variable, like a box that holds a number. So for x in, and then range is, all right, what x should start at. and then end is where x should stop just before reaching this value. So if we want to go to 10, for example, we would put an 11 in here. So it would go up to, but not including whatever value is here. And then what step is it says, hey, do we want to go up in increments of 1, or do we want to go up by 2, or by 4, or do we want to go by -10? We can set that in step. Now again, there's a lot going on here, so let's break this out little by little, and we can type some stuff in the REPL and see how this works. So if we type in code that says for number in range 1, 5, and if we don't put any step in there, it assumes it's going to be 1. What this does is it says, hey, okay, we're going to create a box, a variable, a place that holds data. So you can think of variables as being a box. And this says, hey, start at 1 and go up to, but not including 5. So it'll do 1, 2, 3, 4. Each time I go through here, so starting at 1, it's going to print the number 1. Then it's going to go to 2. It'll print the number 2. 3, it'll print the number 3. 4, it'll print the number 4. Let's go ahead and try that. Hop up over to the REPL. You're probably still there now. And I'm going to type in the code that I just had it there. So I'm going to say for number. And by the way, you can use just about anything in here. So you could call this, Susan or Lee or whatever. But number is a good name because, we're going to be working with numbers in here. What you do want to make sure, though, is you don't use a term that's already been reserved inside of Python. So, you wouldn't name anything print, for example, or brightness or CPX, and, any of the other commands that we'll learn about. But we'll say here for number in range, and then we specify what our range is, so what we're going to start at, and then what we're going to go up to, but not including. So that's why for range, open parentheses, 1, space, 5, and then close our parentheses, and then this is important too. Put a colon in afterward. So just like with while statements, when we had the colon after the true, and then we indent it automatically, well, watch what happens when we press enter here after doing our colon. Now this says, what are you going to do inside of the loop? And what we're going to do is we'll just say print number. So again, we're going to start at 1, we're going to go up to, but not including 5. I'm going to press enter here, and I might have to press enter a few times before REPL picks up what I've typed in, and then it goes ahead and it executes after I pressed it 3 times, and notice it went 1, 2, 3, 4. So it went through, again, number was the value that it changed each time, starting at 1 and going up to, but not including 5. So that's why my results down here, I see it prints out 1, 2, 3, 4 like this. So you could also change this if you wanted to say, you are great 5 times. You could say for, and then just to show you that we can change this to number, you could call this index, or you could call it X or whatever. For index in range 1, and if we wanted to do this 5 times, then we would put a 6 in here and say colon, and then we're not going to use number at all. There's actually a way that we can just put a blank in here, but for now we'll just remember that we're doing an index. When we'll say print, each time we go through, we're going to go through 1, 2, 3, 4, 5, so up to 6 but not including 6, and we'll print you are great, and close quotes and close parentheses, press enter a couple of times, and we get 1, 2, 3, 4, 5 you are greats because we started at 1, we went up to, but not including 6. Cool. So let's take a look at some of the other things that we have on the slide here. If you just put in a range or a number in the range, then what this does is it assumes you want to go through this 5 times. So it'll actually start from 0 and it'll go to 4. But if you know you want to go through that 5 times, or if you know you want to go from 0 to whatever number up to, but not including whatever number you put in there, you can do that as well. So let's go ahead, and I'm just going to use my up arrow here, and I'm going to go into previous statements that I've got, and instead of saying my for index range is going to be 1, 5. Instead, I'm just going to go ahead, or 1, 6. I'm just going to go ahead and put in the 6. I'm going to press enter. Then I'm going to do my up arrow in here until I get to what I had before. You are great. And there's no reason why you can't just go ahead and type this in again, but I know these commands work and it's a little faster. And I'm going to press enter just a couple of times. I think it's twice or 3 times there. And then we see, you are great, 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 you are great. It did this 6 times. It started at 0, and it went through 6 minus 1, which was 5. So 0, 1, 2, 3, 4, 5. That's 6 times that we've got there. Cool. So again, more syntax for us, and my students also have a link to the slides, so you can download these and use these to study from, or feel free to take a screenshot and take notes if you'd like. Now, if you want to go ahead and you want to count down, let's say you want to help Elon Musk and you want to do a down count for his rockets to take off to go from 10 to 0. Well, we can start at 10, a range at 10, and we can end at just before we get to -1, which would mean we end at 0 here. And notice these are whole numbers. They're not fractions. So those are called integers in Python. So we can have no fractions in here. But when we say -1 for our step, instead of increasing by 1, we can decrease by 1. Let's go ahead and type this in. And you know what I'm going to do just to show you that we can do this with different values. I'll say for count in range, and then I'll say 10 comma -1, so that's up to, or in this case it's down to, but not including -1, so it'll go from 10, 9, 8, 7 all the way to 0. I also have to make sure that I put my step in here though, so since I'm counting down, we do a -1. And again, if we don't put a step in here, it just assumes it's 1, but since we have a greater than number, or a number that's greater than in our start value than our up to value, our ending value there, we want to make sure that that's negative, then close with a parenthesis and then colon. And then what I can do here is I can just say print count and just press enter 3 times, and we can see we start off the Elon Musk count at 9, 8, 7, 6 all the way down to 0. And again, we went down to but not including -1, so that's why we stopped at 0. And again, just to give us a little bit more practice here, let's do this last one where we're counting down from 100 through 1, but not to 0, and we're going to be counting down by 5s. So our step is -5 in here. So let's try that. And so we're going to say for, and again, you can use count, you can use number, you can even use, if you want to use X, sort of algebra style in there. So for X in range, start at 100, go up to, but not, or down to, but not including 0. We're going to do it in increments of 5. So that's what our -5 is, our step, since we're moving down here. And we'll just say print, and then this will be X. And if I press 3 times, you can scroll back up here to see I did indeed start at 100, then 95, 90 as expected, all the way down to 5, but not including 0. If I want to go all the way to 0, then I could put a -1 in here. So great, we've got this built up. And so now that we have all of our techniques down, what would be really cool is if we can use what we know about for loops to go up from the 0.0 value in brightness and go all the way to the 1.0 value in brightness. And if we wanted to go up slowly, maybe we would increase by 1/100th. If you think about how you might do this, we'll show you, this would be, a logical thing to think. So if we want to go again from 0 to 1, and we want to go up by 1/100th, 0 is off and on is full brightness, or 1 is full brightness. Maybe we could do for bright value in range 0.0 comma 1.01, so up to but not including 1.01, and we want to use our step as 0.01. So that sounds like that would be great and that should work. Unfortunately, it won't, and the reason why is that the for loop here will not accept anything that isn't a whole number, or they're called integers in computer speak, in Python speak. So we want to go up 100 times, but we can't use integers. But we'll see a workaround that we've got. So what we're going to do down here is we're going to say, okay, the same thing for bright value. You could call this anything, X or N or whatever. But I think, giving it intuitive names, or names that seem to represent what we're doing, I think makes a lot of sense. So we'll say for bright value in range, and we'll say 0 comma 101. And this will start at 0 and it'll go up to, but not including 101. And because we don't have a step value in here, it will step by 1 automatically. And what we're going to do down here is we're going to say cpx.pixels.brightness equals, and we're going to take bright value and divide it by 100. Now, even though this is an integer, as soon as we divide it by 100, it's going to convert into what would be called in Python a float, which is just essentially a value that's got decimal places in it. And we can go up and we'll see the results of this. Now, you know what I'm going to do is I'm also going to put in this print bright value in here. Using print statements is a really great way for you as a new programmer to be able to understand, hey, what's really going on in my code? So if we put a print statement in here just as before, we're going to go ahead and print with each iteration here, starting at 0, 1, 2, 3, all the way up to 100. We'll see what the brightness value is going to be. But you know what? Instead of saying just print bright value, what I'm going to do is I'm going to say, why don't I print bright value divided by 100 so I can see what that number is going to be as I iterate through. So again, some useful techniques for you, hopefully, as you're coding. Let's dive over here and give this a shot in Python. So I'm going to say for, and again, you could call this anything as long as it's not a reserved word in Python. So bright value is a pretty good name, and we'll say in range, and then we're going to start from 0, and we say comma up to but not including 101, and it will automatically step by 1. Then I close my parentheses and I do a colon. And now it indents for me, and this is all the things I want to do in the loop. So you know what I'm going to do here is first I'm going to print things out. I'm going to see what happens when I do print, and I'll do bright value divided by 100. And actually, yep, then I'm going to end it with my parenthesis right here. And so this will go ahead and print out that particular value. I'm going to press enter here, and I'm also going to say cpx.pixels.brightness equals, and I'm going to do the same line that I've got up here, or the same code I should say, bright value divided by 100. And I'm going to paste this in here. And so let's go ahead and see what this does on our CPX when we start this out. So I'm going to press enter and run, and I see it pulses up. It actually does it pretty quickly. So you know what I want to do is I want to change that code, and I want to add a little bit of a time delay in here. Now, we have not imported time, so if we try to do time sleep and then a certain number of seconds or a fraction of seconds, it wouldn't recognize that. So what we need to do here before we can use time, to see that if I do time sleep, so you can see this 1.0 to say, hey, sleep for a second. If I press enter, this is the error that I get. It says, hey, the time is not defined, so I don't know what time is. That's essentially what it's saying. But if I do here, import time in the same way that I did this first line from Adafruit Circuit Playground.express import, that gave me access to all the CPX libraries. This is going to give you access to all the time functions. So I'm going to press enter here, and now if I type in time sleep 1.0, I don't get an error. And I don't know if you noticed, but you're before we saw the next prompt here, the 3 greater than symbols, it waited for a second. So with that said, I'm going to go ahead and I'm just going to use my up arrow because I typed some stuff in here already. And I'm going to find where my for loop started. And yep, I definitely want to enter this. So for bright in range 0, 101. And then I'm going to use my up arrow again just to retype in what I had before, which was my print statement. To take a look at that, we actually didn't even scroll up to see our print statement. We should have done that. And then I'm going to do an up arrow here. And I'm going to show here, this is where I'm going to change my brightness. What I'm going to do down here, each time I go through the loop, what I'll do is I'll say time.sleep, and then why don't I sleep it for 1/10 of the second. So this way we should see, hey, it'll take 10 seconds probably to go from from our completely off to completely on. And you know what? 10 seconds might be just a little bit too much. So why don't we go ahead and delay it by, how about 0.5? So that'll give us for 5 seconds here. So now you're probably at full brightness in your CPX, but if we press enter a few times here, you see how that fades up a little bit more slowly. So that's looking good. Now, what I want you to do is to apply your newfound prowess as a Python programmer. We haven't put any of the code in here, by the way, so if you want to see, hey, how would we go ahead and do this right in our code, because we were doing this all from the REPL, we can go up here, and unfortunately the up arrow doesn't recognize the previous stuff that we typed in, but if you scroll back, and again, we can take a look because we put our print statement in here, we can scroll all the way up here, and we can see, yeah, we did indeed start at 0, and we went by increments of 1, but if you want to grab the whole code that you typed in, we can just go ahead and say, all right, let's go now and grab this line by line. So I'm going to copy my for bright in this range here, and I'm going to put it right under my while true loop. So for true, you've got to indent. So I'm just going to tab over here. And I'm going to make sure that this executes inside of the true loop. I'm going to press enter here again, and notice we're indented now for the for loop. And just to show you, you can actually use print statements when you're running on the CPX as a code.py program. And again, this is really useful for debugging. What you've just got to do is you've got to remember to open your serial monitor. So we're not going to do the Control-C to get into REPL. We'll just go ahead and run this, and we'll see the results. I'm going to go ahead and grab this line of code then. Again, what's nice, and you can see us that we've done this, is we've used the REPL to sort of test out our code. Hey, does it work? Let's try new techniques that we found online when we looked at the documentation. So we've got these 3 bits of code in here, and what I'm going to do is I'm going to go ahead and save, and that for me, but if you want to double click just to make sure, you're going to save it to your CircuitPython directory. So I'm going to say, yep, save it there, replace anything that is there, and you should see once this saves, and in fact even before I reset my CPX, what I'm going to do is I closed serial, and by clicking on it, and then I clicked on it again to open it up, this is actually going to show us this particular print statement in the CPX. But now what I'm going to do is I'm going to reach over to my CPX, and I'm just going to press the reset button, and let's watch what's going to happen here. And nothing happened. And I'm really glad that nothing happened here, because I just made an error. And this will give you an opportunity to think about, hey, what didn't we do here? Because what we want to do is we want to show our blue light, and we want to start at brightness 0 and then go all the way up to full brightness. Well, the first time that you do this, you might not recall this, but the more you get experience in programming, the more you'll recognize things that you may have missed. And what we missed here is we didn't set our color initially to blue. So what we're going to do over here is where it says import time, we are going to say cpx.pixels and then open and open parenthesis, and it's going to be 0, space, 0, space, and this will be 255, and then close parentheses and close parentheses. We could have done this inside of the loop too, but if we're just going to work with blue color, let's go ahead and just set that right up from the start. And now we'll click on save here, and you should see right away, once you click on save, that you see it flash and it starts up. And I'll tell you another thing that we see there. So you might notice, and let me press this again. Watch, it's going to flash at full brightness first. Just very quickly. You see that little flash there? The reason why that happens is because the CPX is going to assume that we're at full brightness right away. So again, how could I get rid of that little flash right away so that I start nice and evenly from all of the lights off? Well, what I could do here is I could just say CPX pixels.brightness, and I can say equals 0.0. And now look what's going to happen when we go ahead and we save this. If I say save, watch your CPX, in there we don't have that flash anymore that happens. We just go right up. Now this looks pretty cool, but it would be nice. You see how it's kind of abrupt right away? We go up nice and slowly. We use our time sleep figure in there. But then when we get to full brightness, we abruptly start again at the 0 value. Wouldn't it be nice if once we got to full brightness, then we started to scale down slowly using our sleep value as well, so that we could make it not only fade up, but also fade down. Fade up and fade down. You know how to do this, and based on what we've just learned, here is what your assignment is going to be. So what I want you to do is use what you've just learned about for loops, counting up and counting down. Remember how we counted down, and converting from the int values, which is what we need for our for loops, into fractional floats, where our brightness values go from 0 off to 1 at full brightness. And I want you to create a Python program that'll do this. And this is what we're going to see down here as I've started the Python program running, or the results of it here. We're going to pulse red instead of blue now. You want to start with the pixels all being off, and then you want to scale up brightness by 1% each time we go through until the pixels are at full brightness, waiting 1/100th of a second between each increase. So again, that's what we see here when we slowly fade up. But then once we're at full brightness, what we want to do is we want to scale the brightness down by 1%. And you see how that's fading down? Starting at full brightness until all the pixels are off, waiting again 1/100th of a second between each decrease. And then what we're going to do is we're going to wait 1 full second before we start over, and we're going to continue to restart over forever. So we're going to loop through this forever loop style. So again, you know how to do this. As you're coding this, remember, you can check your code by using the check button. That can give you some hints if you have a mistake in there or a typo. And you can also use print statements to print out values in the way that we've done it before. That can be really helpful to see, hey, what's going on with my code? How are values changing in here? What are the current values when my code hits this particular part? Just put a print statement in there. Just make sure that you open your serial connection up to see your results. So feel good about what you're doing, Python programmer. And since this is an exercise, you can work with classmates. I definitely want you to code things yourself, but you can work side by side and share techniques and things like that so that you guys can get through this. Keep at it. I know programming is, it can be a little bit of a challenge at first, but a lot of the techniques that we use around logic and ranges and whatnot in programming are also apply in Excel. They'll be very useful when you do some data science work later on in your career as a management student too. So feel good about your skills. Keep at it.